Have you ever wondered what oxidation and reduction really mean? We're about to take a deep dive into these essential concepts. Let's first demystify these two terms, oxidation and reduction. At first glance, they may seem overwhelming, but fret not, simplification is the key. Oxidation is fundamentally about the loss of electrons. Picture being at sumptuous buffet with plates piled high with an elaborate variety of your most loved dishes. The tantalizing sight makes you want to try everything, but the capacity of your plate is finite. You instinctively start to discard the less appealing food items to make room for the ones that whet your appetite. This, in essence, is the process of oxidation. It's about surrendering the extras, the electrons, to create space for something fresh and exciting. And then we have reduction, which is essentially the opposite of oxidation. It involves the gaining of electrons. Now, imagine you're on a shopping spree during a massive sale. Your cart is already brimming with items, yet when you spot an irresistible deal, you can't help but add it to your cart. This is reduction, the process of adding more, of gaining electrons. Let's illustrate these concepts with a straightforward example, the rusting of iron. Upon exposure to oxygen in the atmosphere, iron oxidizes to form rust. The process involves the iron surrendering electrons to the oxygen, thus undergoing oxidation. Simultaneously, the oxygen is receiving these electrons, hence it is undergoing reduction. So during the rusting process, the iron and oxygen participate in an intriguing dance of oxidation and reduction. This will hopefully give you a more lucid understanding of what these terms mean. However, it's vital to remember that these processes do not function in isolation. They are akin to partners in a dance, continuously moving in sync, constantly balancing each other's movements. In summary, oxidation is the process of losing, while reduction is about gaining. But how do these two seemingly opposing processes coexist? Be prepared to delve deeper as we are about to journey into the captivating realm of redox reactions up next. Do oxidation and reduction sound like opposing forces to you? Well, they're more like dance partners in a tango. Let's imagine a ballroom where oxidation and reduction are not enemies, but partners, each performing their roles to perfection. In this dance of chemistry called a redox reaction, one substance struts the steps of oxidation while another gracefully glides through reduction. So, what exactly is happening in this dance? Well, oxidation is the process in which a substance loses electrons. Picture this as a dancer twirling, her flowing dress representing the electrons being lost in the whirl of movement. On the other hand, reduction is the act of gaining electrons, much like a dancer catching a tossed rose, the rose symbolizing the gained electrons. Now, in the dance of a redox reaction, these two processes occur simultaneously. As one substance loses electrons, another gains them. It's a beautifully choreographed exchange, an elegant tango of give and take. Let's take the example of a reaction between hydrogen and fluorine to form hydrofluoric acid. In this reaction, hydrogen is oxidized, meaning it loses its electron. Like a dancer spinning wildly, hydrogen releases its electron into the dance floor of our reaction. At the same time, fluorine is reduced, meaning it gains the electron that hydrogen has lost. Like a dancer swooping in to catch a thrown rose, fluorine sweeps up the electron released by hydrogen. This mutual exchange results in the formation of hydrofluoric acid, the grand finale of our redox reaction. This dance, while complex, is fundamental to many processes in our world. From the rusting of iron to the functioning of our bodies, redox reactions are happening all around us. So, oxidation and reduction go hand in hand, each enabling the other in a redox reaction. They're not opposing forces, but dance partners, twirling and sweeping across the dance floor of chemistry, creating the beautiful tango of redox reactions. But how do we keep track of the electrons during these reactions? Enter the concept of oxidation number. Think of oxidation numbers as a way of keeping score in a game. They're a measure of the number of electrons an atom uses to bond with atoms of another element. It's like figuring out who's passing the ball in a game of football, but instead of a ball, we're dealing with electrons. Let's take a simple example to illustrate this. Water, or H2O. Water is composed of 2 hydrogen atoms and 1 oxygen atom. Now, hydrogen is a bit of a modest player. It has 1 electron which it's willing to share. Oxygen, on the other hand, is a bit more ambitious. It has 6 electrons in its outer shell, but it's looking for 2 more to complete its shell. So when 2 hydrogen atoms come together with an oxygen atom to form water, Each hydrogen atom shares its one electron with oxygen. This is where the oxidation numbers come in. We assign a positive oxidation number to hydrogen, indicating it has lost control of its electron. In contrast, we assign a negative oxidation number to oxygen, indicating it has gained control of these extra electrons. The oxidation numbers for this reaction would look something like this. Hydrogen, with its lost electron, gets a +1. Oxygen, with its gained electrons, gets a -2. These numbers help us understand the transfer of electrons in this reaction, with hydrogen passing the electron ball over to oxygen. But remember, these numbers are just a tool to help us understand what's going on during these reactions. They don't change the basic nature of the atoms involved or their physical properties. So, oxidation numbers are like scorekeepers in our redox reactions, keeping track of the electron game. Isn't it fascinating how these fundamental processes drive so many reactions around us? As we traverse through the captivating domains of science, these intriguing concepts of oxidation and reduction truly stand out. They are the unseen forces that power a myriad of chemical reactions and transformations around us. Let's jog your memory a little. We started our journey by exploring the concept of oxidation, didn't we? A process where an atom, ion, or molecule loses an electron. Imagine a bustling city and electrons are the currency. Oxidation is like spending your money, releasing the energy stored within. Then we moved on to its antithesis, reduction, a process where an atom, ion, or molecule gains an electron. To stick with our city analogy, reduction is akin to earning money, accumulating energy. Oxidation and reduction, two sides of the same coin, working in tandem to drive the world of chemistry. Next, we dove into the dynamic dance of redox reactions. These are the reactions where oxidation and reduction occur simultaneously, a beautiful ballet of electrons, if you will, where every loss is balanced by a gain. It's this elegant balance that powers everything from our bodies to our batteries. And who could forget the role of oxidation numbers? This is the tool that helps us keep track of the electron ballet. It's like the scorecard in a game, helping us understand who's gaining, who's losing, and how the balance is being maintained. All of these concepts, oxidation, reduction, redox reactions, and oxidation numbers, are not just theoretical constructs. They are practical, real, and omnipresent. They are at the core of life's processes and human-made innovations alike. We hope this video piqued your interest in the captivating world of chemistry. If you have any questions, feel free to drop them in the comments section. We're here to help unravel the mysteries of science. Don't forget to like, share, and subscribe to our channel, Facts Academy 0122. Your engagement fuels our passion for bringing more intriguing scientific concepts to light. Stay curious and keep exploring.